Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day everyone. Thank you for attending these sessions. My name is Asma-Qamaliah binti Abdul-Hamid, and today I will share one of my study together with my colleague Professor Dr. Muhammad Helmi Ali and Dr. Jauhan Zhang, which is the study entitled Navigating the Complexity in Circular Supply Chains in Identifying the Barriers and Causative Factors in Chinese Constructions. So basically this study is positions within the sustainability transformations that aim to understand not only what are the barriers that exist in this sector, but also how does the barriers could influence one another within the complex system. So basically this is the content for our discussions today. Alright, so this study actually want to focus on the constructions sector, as we believe that this sector actually plays a critical role not only from the perspective of the economic, but actually this sector are one of the largest contributors to the waste and the environmental impact. So mainly this circular supply chain aims to close the resource loop by reducing the waste, enabling the reuse, and also regenerating the materials. So meanwhile, the industry 4.0 technology like the Internet of Things, IoT, AI, and also the data analytics actually can improve the traceability as well as the efficiency across the supply chains. And from this integration, we believe these two concepts will have a strong potential to enhance, to improve the sustainable construction practice. However, from the literature, we have discovered that these adoptions has remained under exploit in the Chinese construction industry due to the barriers that are not well understood, especially in terms of their interconnected nature. So based on the previous study, we have understand that the barriers are treated as the isolated barriers. So in this study, we try to argue that the constructions sectors are operated as a complex adaptive system, meaning to say that the barriers actually are interconnected, and sometimes these barriers also could reinforcing each other in non-linear ways. And for that reason, the study want to adopt the complexity theories to have a better explanations that the dynamic interactions among the social, economic, policy, and as well as the technological constraint. So instead of we try to know or asking only what are the barriers, actually in this study we also want to know and explore what are or which ones could drive the others barrier. So in this study, the aims we want to highlight is to identify and model the critical barriers that prevent the Industry 4.0 and circular supply chain integration, specifically in the Chinese constructions. And the first objective we want to achieve is to validate which barriers or criteria would be the most important. And the second objective is to map out or determine the causal network among these barriers by identifying the root of causes that could influence the others barrier. So we also expected that this study could contribute in the practical ways by guiding the policymakers together with the practitioners on which issues must be prioritized first in order for us to accelerate the sustainability transitions. So to achieve this, we have adopted a hybrid method. The first one is the fuzzy Delphi method, which we use to screen and validate the barriers by capturing the expert consensus under uncertainty. And the second method we have adopted is the fuzzy method, in order for us to identify the cause and effect relationship among the accepted barriers. And in this study, the data were collected through the interviews and the questionnaire feedback from the 11 experts that have covered the academician, industrial practitioner, and the government officer viewpoints, in order for us to provide a balanced perspective of the sector. So this is the results that we have collected from the fuzzy Delphi method analysis that have resulted in 21 critical barriers that has exceeded the screening threshold. And these criteria were grouped into the 6 aspects. For example, include the lack of collaboration across the stakeholder, unclear institutional goals, high initial investment, and the recycling costs, as well as the complex or overlapping regulations and lengthy approval procedure. And from this result also, we have confirmed that the barriers are distributed across the organizational, economic, regulatory, and technological dimensions. So next, we also have adopted the fuzzy method that has classified the barriers into a cause and effect groups. At the aspect level, we have identified that the social barriers, policy and standard barriers, and the technological barriers has emerged as the cause group drivers. And these barriers drive, or we also can say that these barriers has triggered other barriers such as the economics as well as the operational constraint. This means that we need to tackle these cost group barriers will create the ripple effect by reducing many downstream challenges. So in details, at the criteria level, the D method has highlighted that 9 key barriers with the strongest causal influence are included as the unclear internal goals and lack of collaboration, which has shown that the organizational readiness and the commitment are foundational. And in terms of the economic barriers such as the inadequate financial resources and high costs also are strongly constrain the adoptions. In terms of the regulatory issues such as the complex and overlapping the regulation, insufficient government support, and the lengthy approval process are also shown as the emerge as the major drivers, and together actually these drivers represent the leverage point for interventions. So to conclude this, the integrating the Industry 4.0 and circular supply chain actually could offer a strong potential for the sustainability in Chinese construction, but actually it will remain difficult due to the interconnected barriers. And this study actually has shown that the root drivers come primarily from the social, policy and standard, as well as the technological barriers, meaning to say that these aspects should be addressed first. And in terms of the practical recommendations, include that we need to clarify the internal sustainability goals by strengthening the collaborations across the stakeholders. We also need to simplify the regulatory that has overlap. We also need to increase the incentive and the financial mechanisms, as well as develop the digital skills through the training and capability buildings. So by focusing on these root causes, actually the policymakers and the industry leaders can accelerate the adoptions and unlock the broader sustainability outcomes. So with that, I think I will with that conclusion, I end my presentations. So thank you everyone.